Bismillahirrahmanirrahim. Assalamu alaikum. Exercise 2.2, Unit number 2. The title of Unit number 2 is Matrices and Determinant. In this video lecture, we will discuss some question of exercise 2.2. Question number 3. The statement of question number 3 is, let A be a square matrix. A be a square matrix of order 3, mean there are 3 rows and 3 columns. Then we need to verify that the determinant of the matrix A and determinant of its transpose are equal. This A to the power T mean the transpose of A. You can also write it A power T. This represents the transpose of A. This is the question. Now this question is given in the journal form. Here a matrix A is given, which is a square matrix of order 3, mean in this square matrix A we have 3 rows and 3 columns, and we need to verify, we need to prove that the determinant of the given 3 by 3 square matrix is equal to the determinant of the transpose of this square matrix A. We need to show this. But this question in the journal form, you didn't see that the given matrix is a particular 3 by 3 matrix. So therefore we will consider a square matrix in journal form of order 3 by 3. So let us consider, let A be a square matrix of order 3, that is A equal to a matrix which contain the elements in the journal form, and the order must be 3 by 3, mean there are 3 rows and 3 columns. So A11, A12, A13, A21, A22, A23, A31, A32, A33. Why I am considering the matrix in the journal form like this? Because the subscript shows the position of the element that it present in that row and that column. For example, if I choose this element, so this is present in the second row and third column, so that's why in the subscript we write small, in the subscript of small a we write 2 3, 2 for the row and 3 for the column. So this is a beautiful notation whenever you are writing the journal matrix of any order. So this is of the order 3 by 3, so you must write it in this form. Now this is a journal square matrix of order 3. The target is, we need to check, we need to verify that the determinant of this matrix and the determinant of the transpose of this matrix are equal. This is our target, we need to show this. So first of all, I am finding the transpose of this matrix, and then I will take the determinants of A and the determinant of the A transpose, and then we check that either both of them are equal or not. If they are equal, then we can say that we achieve our target or goal. Now you know what is the transpose of a matrix. Transpose of a matrix is obtained when you interchange rows into columns or columns into rows. Mean if you write the first row in first column, second row in second column, third row in third column, or first column in first row, second column in second row, third column in third row, so that is the definition of the transpose of a matrix. So therefore first find A transpose. Sometimes this transpose is also denoted by this, by capital T. So sometimes we use A power small t or A power capital T. Both are the representation for the transpose. So this is our first target. So A transpose will be equal to a matrix in which you need to convert the rows into columns or columns into rows. It is your choice. So I am converting rows into columns. So the first row is written in the first column. You see that the second row of a matrix A is written in the second column. The third row of a matrix A is written in the third column. So this is the transpose of the given matrix. Now you need to take the determinant of this matrix A and the determinant of the transpose of matrix A. And remember that whenever you take the transpose of a matrix, so that transpose is also a matrix. So now I am taking the determinant of the given matrix A. So you know determinant can be found with 6 possible ways when the order is 3, because there are 3 ways to find the determinant by using rows, and there are 3 ways to find the determinant of the given matrix A by using columns. So the choice is yours. You can use rows or you can use columns. The choice is yours in this case. But whenever a particular matrix is given, so you must need to take such a row or such a column in which there are maximum number of zeros. So that element which multiplied with the cofactor, you didn't need to find out the cofactor of the element which is 0. So in this case I am expanding the given matrix with the help of the first row. So you must write it here, expanding, or you can write finding the determinant expanding A with respect to first row. So according to that, the formula for the determinant must be A11 capital A11 plus A12 capital A12 A13 capital A13. Now you need to find out the cofactor A11. So cofactor A11 is actually equal to minor M11. So I can replace this cofactor by M11 because the addition of the subscript is even. Now this is A12 and this capital A12 is equal to minus times M12 because the addition of the subscript is odd, and this will be plus A13 M13. Now you can also write it in this form. Now to find out the determinant of matrix A, we need to find out M11, M12 and M13. So what is M11? You need to cancel out the first row and first column and take the determinant of the rest of the matrix. So you will get M11. So this implies that this A determinant, this is A11, this M11 will be equal to the determinant of the matrix when you cancel out the first row and first column. So this first row and first column will be cancelled. The rest of the matrix will be written in the determinant form. So this is the rest of the matrix which I am writing in the determinant form, minus A12. Now how you can find out capital M12? Mean you need to cancel out the first row and second column, first row and second column, and take the determinant of the rest of the matrix. So this is M12, 21, A23, A31, A33. Now plus A13. How you can find out capital M13? You need to cancel out the first row and third column, and take the determinant of the rest of the matrix. So that is A21, A22, A31, A32. Now you see that these determinants of order 2 by 2. So you need to find out the definition for the determinant of order 2 by 2 is you need to multiply the diagonal elements, then put a minus and then multiply non-diagonal. So you will get the determinant. So this implies that A determinant will be equal to small a11. This will be A22, A33 minus A23, A32, then minus A12, this will be A21, A33. I am multiplying the diagonal elements, then minus, and the non-diagonal elements, A23, A31. I am writing it here, plus A13, and multiply the diagonal elements, A21, A32 minus A22, A31. So this is the determinant of matrix A. Let us name this with 1. Okay, now I am finding out the determinant of the transpose of a matrix A. Okay, so the transpose of a matrix A is this. Now I am finding out the determinant. So for the determinant of the transpose of a matrix A, use first row. I am using first row. So expanding with respect to first row, the transpose of a matrix A determinant will be equal to, now you see that this is your first row, this is your first row, this is your first row. But remember, whenever you are expanding a matrix with respect to first row, so the formula will be in general written in this form. But in this case, you clearly see that in place of A11, mean the element which is present in first row and first column is A11. So this is A11, capital A11. Now the element which is present in the first row and second column, this is A21. So you must replace this A12 by A21, and the cofactor must be in the form of A21 because you are expanding it with respect to first row. And similarly, this is the element which is present in the third row, in the first row and third column. But so that's why I am replace this A13 by A31, and this capital A13 must be as it is. Okay, so this is an important point. Now this implies that A11, this capital A11 is equal to M11 because the addition of the subscript is even. This must be minus M12 because the addition of the subscript is odd. So that minus is multiplied with plus, so that become minus. So this is A12, then this will be plus A31, capital A13, M13, sorry. Now this is A11. How you can find out the M11? Okay, so you need to cancel out the first row and first column of the matrix which is the transpose of the matrix A. So cancel out the first row and first column. Whenever you cancel the first row and first column, take the determinant of the rest of the matrix, so that will be capital M11. So A22, A32, A23, A33 minus A21. How you can find out M12? You need to cancel out the first row and second column and take the determinant of the rest of the matrix, which is A12, A32, A13, A33. And similarly, when you are finding M13, so you need to take the determinant of the matrix when the first row and third column is cancelled. So the rest of the matrix will be A12, A22, A13, A23. Okay, now you need to expand the determinants of 2 by 2. So diagonal elements will be multiplied with the diagonal, and non-diagonal will multiplied with non-diagonal, and there will be minus in between. Minus a21 minus a21, and this will be a12 a33 minus a32 a13 plus a31 a12 multiplied by a23 minus a22 multiplied by a13. Okay, so this is the determinant of the matrix A transpose. Now if you compare the determinant of the matrix A and the determinant of the matrix A transpose, so you see that both of them are equal. You see it here. This is a11, this is a11. Now a22 a33, a22 a33. Now this is a23 a32. So it is also a32 a32, a23 a23. Now these are the elements of the matrices, and you know that element of the matrices are real or complex number, and you know the commutative property with respect to addition and multiplication are hold in the set of real and complex numbers. So that's how you can write this a23 a32 instead of a32 and a23. It is the same. Now in this case, if you see, this is the a21 and here is a12, but if you see it here, so this is a21 a33, so here is a12 a33, and here you see that there is a 32 and a 31, so this is also change. So when you multiply all these elements and then add and subtract, and when you multiply all these elements and add and subtract, so they must be equal. That must be equal. If you see here, it is a 13 and it is a 31, but here it is a 21 and here is a 12. It is a 32 and it is a 23. So there is a difference, but whenever you multiply all these and then add and subtract, and when you multiply all these and add and subtract, you will get the same result from equation 1 and equation 2. So remember, from 1 and 2 we can say that from 1 and 2 you can verify. You need to multiply, add and subtract, you need to multiply, add and subtract, and then compare equation 1 and equation 2. You will get the same result. So from 1 and 2 we can say that we have the determinant of matrix A is equal to the determinant of the transpose of a matrix A. This is your assignment to verify this, that how A determinant mean equation number 1 and A determinant A transpose determinant, which is equation 2, are equal. So you need to multiply this A1 with this, minus A12 with this, plus A13 with this, and you need to multiply this with this, minus A21 with this, plus A31 with this, and add and subtract, and then you will see that equation 1 will be equal to equation 2. So that's why we can say that the determinant of a matrix A is always equal to the determinant of the transpose of that matrix. And this is also the first property for the determinant, that whenever you interchange the rows or the columns, the determinant must be remain the same. This is the property number 1, and this is the proof for the property number 1. But you need to verify this equation 1 and equation 2 must be equal. You just need to multiply, do the addition and subtraction, you will get equation 1 equal to equation 2. So then we can write that A determinant is equal to A transpose determinant. So this is the question number 3 of exercise 2.2. Thank you.